Hello, good day! So welcome to another math video tutorials. This time it's all about division of radicals. In dividing a radical by another radical, we rewrite the expression to fractional form and then rationalize the result like what we did in simplifying radicals involving fractions. The pairs of expressions like x minus square root of y and x plus square root of y, or 3 plus square root of 2 and 3 minus square root of 2 are called conjugates. The product of a pair of conjugates has no radicals in it, hence we rationalize the denominator that has two terms where one or more of them involves square root radical. So in division of radicals, we're going to utilize conjugates in order to eliminate radicals in the denominator. So let us try to answer the first two examples that we have here. So number 1, we have square root of 2 over square root of 3. In playing division, so that is square root of 2 divided by square root of 3. So the rule is there should be no radical sign in the denominator. So what we're going to do is to rationalize the denominator by multiplying the numerator in the denominator by what is in the denominator. So we have square root of 3. So we have square root of 3 here and square root of 3. So this one is the rationalization process. So you just multiply. So we have square root of 2 times square root of 3. It is square root of 6. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. So the final answer is square root of 6 over 3. So you will notice there is no radical sign in the denominator for the final answer because it is not allowed in the rationalization process. Okay, next we have, for number 2, you have square root of 2 divided by or over 2 plus square root of 3. So here you will notice that we have two expressions. You have 2 and then you have plus square root of 3. So what we do here is we get the conjugate of the denominator. So when you say conjugate, there is operation between the two expressions. So we get the conjugate or its opposite. So you have 2 plus square root of 3, so that will be 2 minus square root of 2 as your conjugate. So both numerator and denominator will be multiplied by 2 minus square root of 3. Okay, so we have to multiply square root of 2 in this expression. So you have square root of 2 times 2. We have 2 square root of 2 minus square root of 2 times square root of 3. We can direct it answer as square root of 6. And then in the denominator, so we can apply here the sum and difference of two terms by multiplying the first term. So you have 2 times 2, which is 4. Positive, negative, so that will be negative. It's just like positive times negative. It will give you negative or minus square root of 3 times square root of 3, which is square root of 9. So going back to the numerator, so you have 2 square root of 2 minus 6 all over 4 minus square root of 9, which is 3. Okay, so just simplify. So 4 minus 3, of course, that is 1. So any number in the denominator over 1 is the number itself. So the final answer will be to square root of 2 minus 6. Okay? That's the final answer. Okay, next we have examples 3 and 4. So for this type of division, you will see that we can directly divide the numbers outside the radical sign and inside the radical sign. So 20 square root of 3 divided by 5 square root of 3. So we can think of it as direct division. So it's 20 divided by 5. So that will be 4. And then square root of 3 divided by square root of 3. Square root of 3 divided by square root of 3 is 1. So the only answer here is 4. Okay. Next, for number 4, same thing. We can directly divide the numbers outside and inside the radical sign. So we have 10 divided by 2. So that will be 5. Square root of 18 divided by square root of 9 is square root of 2. That is allowed in division of radicals since we can directly divide, or we can say there is exact division for particular in radicals inside and outside the radical sign. Okay, then number 5, numbers 5 and 6, you will see here that for number 5 we have the same radical but different in index. Okay, then for number 6 you have, might as well, no? You have this here you have the same index but different radical. Okay, so let us try to answer number 5. So we have square root of 2 divided by the cube root of 2. So we can, first step here is we transform radical sign or radical number into fractional exponent. So you have square root of 2, so that's 2 raised to 1/2 over, for the cube root of 2, that's 2 raised to 1/3. Okay, and then same similar process what we did in multiplication of radicals. We have to make these fractions, fractional exponents, as similar fractions. So for this fraction, you have 1/2 and 1/3. So the LCD, you have to find the LCD, which is 6. Okay, so you have 6 times 1 divided by 2. So that's 2 raised to 3/6. And then in the denominator, you have 6 times 1, 6 divided by 3. So that's 2. So 2 raised to 2/6. So they have now the same denominator. We can write this as a single radical since they will share the same index. So that will be the 6th root of, in the numerator you have 2 cubed over 2 squared. And then we just simplify. So that will be the 6th root of 2 cubed is 8, 2 squared is 4. Okay, so that is 8/4. Or we can apply here quotient of powers actually. So the final answer here will be the 6th root of, we can divide this, 8 divided by 4, that is 2. Or here, just subtract the exponents using quotient of power. So that's 3 minus 2, that's 1. So 2 raised to 1 is still 2. So the final answer is the 6 root of 2. Okay, next, our last number, we have the cube root of 4 divided by cube root of 6. So here we can rewrite this, since they share the same index, as the cube root of 4 over 6. And then we can reduce 4 over 6 to lowest term. That's the cube root of 2 over 3. But we have to multiply the denominator by 3 squared and the numerator as 3 squared as well. So why we have to do that? Since the index is 3 and the denominator here will be 3, so we have to add 3 squared in order to, once we add 1 and 2, they will have the same index. Okay, since as we all know, there will be no radical sign in the denominator, so we have to rationalize. So this is the rationalization part. So what we are going to do here is to directly multiply 2 and 3 squared in the numerator. So you have 2 times 3 squared, so the 3 squared is 9, 2 times 9 is 18 over 3 times 3 squared is actually 27, which is a perfect cube number. That's why if you're going to get the cube root of 27, so the final answer here will be the cube root of 18 over 3. So the radical sign in the denominator is already eliminated. So this is the final answer. So those are the situations on how to divide radicals using conjugates, then rationalization, and then direct division as well. Okay, so I hope you learned something today. Thank you for watching. If you have any questions, you can comment your questions below. Don't forget to hit subscribe, hit the notification bell for more updates. Thank you very much and have a good day.